Section 3, Raster Spatial Analysis. In this section, we'll learn how to use raster data in a GIS environment. We'll then use functions in the Spatial Analyst extension to ArcGIS to reclassify rasters and perform raster overlay. Viewers will then learn how to perform spatial analysis using raster data and analyze landscape surfaces with slope, aspect, and viewshed tools. Raster data, core principles. In this video, we will review the basics of raster data in a GIS environment. We'll also discuss how rasters are represented in a GIS, and then preview a raster dataset in ArcMap. Raster data are characterized as a grid of cells that form a continuous surface, and they're generally optimal for representing geographic information that varies continuously over space. So topics such as land use, temperature, elevation, those are excellent topics to represent using a raster data model. In the raster data model, each grid cell contains a value that represents some real-world phenomena. It could be an elevation value, it could be some sort of land use category. For example, in this hypothetical raster that we see on the screen, we have cells with a value of 1 that represent forest area, cells with a value of 2 that represent water area, cells with a value of 3 represent residential areas, and then 4 represents agricultural. Raster data can be characterized as either quantitative or qualitative. A quantitative raster might be well exemplified by elevation data, in which each grid cell represents some measured or estimated elevation value relative to some sort of vertical datum, for example, mean sea level. And so the elevation raster on the left-hand side shows quantitative variations in the elevation of the landscape, here around Tarrant County in Texas. The land use raster to the right is an example of a qualitative raster, in which the grid cells represent nominal information. That is information that you're not going to do mathematical operations on, but rather that represent categorical information, such as urbanized area or water or agricultural area, and shows those variations around the county. Raster data are characterized by their cell dimension and their resolution. The cell dimension of a raster dataset represents the size of each grid cell. Commonly, you'll run into rasters that are, say, 30 meters by 30 meters. This means that the grid cells have a dimension of 30 meters on each side. Cell dimension is then related to the resolution of the raster, which refers to the relative size of each grid cell. A low-resolution raster will have larger cell sizes, whereas a high-resolution raster will have smaller cell sizes. For example, in the images on the screen, you see the same area represented as a low-resolution raster with a cell dimension of 15 meters, and a high-resolution raster with a cell dimension of about 15 centimeters. Now, the image on the left is much more difficult to make out, say, individual houses, but also the dataset will be much smaller. And so if you don't need that level of precision, you might be interested in a lower resolution dataset, which will be faster to work with. If you do need, say, house-level precision, the high-resolution raster will be the way to go. There are many, many different types of raster data that we use in a GIS environment. ArcGIS and other GIS packages can handle many of these raster formats, which might include raster image files, JPEG, TIFF, PNG, bitmap, etc. Those can all be represented as rasters in a geographic information system like ArcGIS. Variants of these geo-enhanced image files are similar to the raster images but have embedded or associated geographic information, such as relative position on the Earth's surface, a coordinate system, which facilitates display and in turn analysis in a GIS environment. There are also Esri-specific formats, including file geodatabase rasters, which we'll get acquainted with in just a minute. We might also work with remotely sensed imagery from remote sensing packages. There are many, many more types of raster files that you'll run into in a GIS. ArcMap can work well with most of them. And so now I want to spend a little bit of time exploring raster data in ArcMap. We'll be working in particular with 2 raster data sets. One that's representing 2 particular time periods, and one that's representing elevation. And so what I'm going to do now is I'm going to move over to ArcMap, and inside of a blank ArcMap document, I'm going to click my Add Data button, the same way that I would say add a vector dataset to ArcMap. I click the button and navigate to my rasters geodatabase, and I see that I have 3 rasters inside. Clark 2001 and Clark 2011 are land use rasters, representing 2 particular points in time for Clark County, Nevada, which is the area around Las Vegas. The third raster, Meade DEM, is an elevation raster of the area around Lake Mead in Nevada and Arizona. We'll be working with that in later videos. In the meantime, I'm going to choose my 2011 Clark raster and click Add to add the raster to my map display. I see here that I have a raster that's been clipped to the extent of Clark County, Nevada, and I have a variety of different colors, each of which represents different land uses. We'll be going into these categories in the next video, but you might already be able to make out some geographic features. The red area represents urbanized or developed area, so Las Vegas and its suburbs. The blue area represents water, so you can see parts of Lake Mead to the east of Las Vegas. Indeed, you can zoom in, just like you're accustomed to doing in ArcMap, and use the Identify tool to click anywhere on the map and identify then the particular grid cell on which you clicked. In this case, I clicked on a grid cell with a color index value of 24, representing highly developed urbanized area. Interestingly, I get a count of grid cells for that color index in the entire dataset. One thing you can do with qualitative rasters is you can view their attribute tables, much like you would with vector data. To accomplish this, we right-click our raster in the table of contents, and we choose Open Attribute Table. An attribute table appears that shows us the different cell values in the dataset and then gives us the number of cells in that dataset that correspond to those values. As you can see here, we're dealing with a dataset of millions of cells. We'll talk more about these categories in the next video. We can also view some more information about our raster by right-clicking the layer in the table of contents and then choosing Properties. This opens up the layer's properties. If we click the Source tab here, we get some basic information about our raster. You see here the cell size or cell dimension, 30 by 30. In this case, that's referring to 30 meters by 30 meters. If we scroll down further, we'll get some information about the extent of the raster and the spatial reference, the coordinate system used by this raster dataset. In this case, we're using Universal Transverse Mercator Zone 11 North with the datum, North American datum of 1983.